Spark plugs require a high voltage of more than 10,000 volts to generate sparks, but as we have seen, the vehicle's only source of electrical power is a 12-volt battery. So how do we generate a high voltage from a 12-volt power source? Let's explain. Take a look at this experiment. A 100-volt lamp is connected across the battery and the switch is turned on. The voltage is only 12 volts, so the lamp doesn't light. Next, a coil is connected across the lamp and the circuit switched on once more. Once again, the lamp fails to light. But at the instant the switch is turned off, the lamp flashes. Here's why. If the switch is turned off when current is still flowing in the coil, a large electromotive force, EMF, or voltage, is generated, flowing in the opposite direction. This is called the self-induction effect, and the electromotive force generated is called the counter-electromotive force. Next, let's do another experiment. Two coils with different thicknesses of wire and numbers of windings are connected in series. The moment the switch is turned off, the flow of current in the primary coil is cut, generating a greater current in the secondary coil. Current is switched on and off in the primary coil, a high voltage is generated in the secondary coil. This is called the mutual induction effect. An ignition coil integrates these two coils into one. Let's conduct a test with an actual ignition coil. The current flowing in the primary coil is turned on and off. As you can see, the ignition coil uses the self-induction and mutual induction effects to generate a high electromotive force of tens of thousands of volts from the 12-volt power source. Conventional systems use conductive breaker points in the distributor to turn the switch on and off mechanically, just like this device. But today, most systems make use of the switching effect of a transistor or an electronic control unit, or ECU. Now let's take a close look at how a high voltage is generated using an actual transistorized ignition system.